Hey, South Carolina's math industry, and we are going to understand that there are not just one way to solve a problem. There are actually many ways to solve a problem, not just in math, but in real life. But what we're gonna do is we're gonna try to find the area of a triangle. And there are two ways we can do it. And we're also going to show it. If there's another way you can find the area of a triangle, type in the comments below what you found about it. So,
wonderful, Peachy. Now how am I supposed to get 2 SpongeBob so I can hand them these order tickets here?
Problem solved.
Squidward, hi.
Oh, it's days like this that make me wish I had gone to college.
when you do the area of a triangle, the area is with a formula. So A equals base times height divided by 2. The base times the height is going to resemble a square. But when we divide it by 2, we get 2 equal triangles. So that is the formula for a triangle. Base times height divided by 2 will get you 2 equal triangles. But we're measuring just one. If you ever like to experiment with mathematics, and you also like to find as many solutions you can, well, that's what we're gonna do today. What we're gonna do is show how this method right here can give you the exact results for this method right here when we use the integral. So let's get started. This is what the picture looks like when you graph it. You have 0 right there and 5. Actually, we're going to put 10 up there. We're going to change the problem to 10. So that is saying, what is the area of this triangle when you mark it from 0 to 10 on the x-axis? If you ever watched our video on finding the area under a curve, we're going to do that process. So first we have to worry about the letter x. And what we're going to do is try to find the antiderivative of that letter x. So going back from our calculus video from the last time, when you have an antiderivative, when you have x to m as your exponent, when you have a variable to an exponent, finding the antiderivative requires you to have a variable represented as x, and you have to have your exponent plus 1. So you have to add the power by 1, or the level if you're a video game person. Then we have to divide it by your exponent plus 1. And that is an antiderivative, trying to find what's inside this thing, or this shape. So we're going to put x squared, well, we're just going to put x there. X to the power of 1 plus 1 is x squared. Divide that by 1 plus 1, so x squared divided by 2. We have 2 more steps we need to do, and it makes it very, very simple. We have x squared divided by 2, so now here comes the 0 and the 10 come in play. We're going to write x squared divided by 2 right there. And we're also going to put brackets around it, because there are 2 scenarios that we're going to look at. So we have 0 and 10. What is the area inside this shape? We're going to put 0 and 10 right there, because those are the boundaries that we're trying to find inside the shape. We have to insert them in for x. So 0 times 0 representing as x. 0 times 0 is 0. Anything divided by 0 is undefined. You can't divide... wait, it's not undefined. It's okay. So, 0 divided by 2 is going to represent 0. It's the other way around. When you divide by 0, it's undefined. But when you have 0 divided by another number, it is okay. It represents as 0. So 10 times 10 is 100. Divide that by 2 is 50. We did that because we wanted to find the differences between the two to find this shape right there. 50 units squared. That is what we got for this version, the integral part. What do we do for this one? Well, doing this formula, we have 10 times 10. That'll bring us to 100. 100 divided by 2 is 50 units squared. The reason why we say squared in the first place is because they're 2D shapes. And guess what happened? We got 50 for this inside here, and 50 for this for inside here. So, what we're trying to explain here is even though there's an easy and a hard way, you actually get to experiment and get to the same answer, no matter which way you do it. But one way is more efficient than the other way. I'm going to say this one is more efficient because there's a formula with it. What we're trying to explain is that there are more ways to solve a problem than you think. No joke, but there's 350 ways to actually prove Pythagorean theorem. More than 350 ways. I hope this video has helped you understand that there are a lot of more solutions. Thank you for watching Tao Penalized Math Industry. Like and subscribe.
They're everywhere!
Mr. Krabs!
Stay back! Take Squidward, not me! Oh, hi, Squidward.
Mr. Krabs, we gotta do something. The customers are mad with hunger. They're beginning to riot.
For once, he's right.
Easy, boys, easy. Don't you think you're both getting a little carried away? I mean, hard to call this a riot, right? Like, okay. Don't worry, I can solve this. More drive-thrus, more money. Hey, somebody eating potato chips?
Don't worry, Mr. Krabs. We can fix it. We might need to buy some more toothpaste, though.